Hello, you're watching section 5 of part 5 of building a web application using ASP.NET Core 1.0, Aurelia, TypeScript, and Webpack in Visual Studio Code. This will be the last section of part 5. In this section, I'm going to be talking about server-side implementation of Contact Manager in ASP.NET Core 1.0 using C#. Then we'll see what is a generic entity interface and the advantages of that, and a entity base implementation, which is an abstract implementation of that interface. Then we'll create a contact POCO model. POCO is an acronym for plain old CLR object, which means that it is going to be a simple C# class without any dependencies on any other libraries. A generic repository interface and what is the advantage, and then an in-memory implementation of that repository. Then we'll define a specialized implementation of the repository specifically catered for handling contacts objects. What is ASP.NET Core dependency injection? Dependency injection is now a first-class citizen in ASP.NET Core. So we'll leverage the DI container and the DI APIs to inject or to register our repository interface as well as the concrete implementation. After we do that, we'll create an API using the controller, and then we'll test the web APIs using the tools like Postman and Fiddler. You could use either one of them, but I'll show both of them. Then we'll write the contact service on the client side, and also we'll wire the contact service into contact list and contact detail view models. Okay, then now let's jump into the server-side implementation of Contact Manager. The first thing we want to do is to create a models folder. This is going to be on the server side. We'll create a models folder and we'll create the model interfaces and classes. The first interface will be iEntity.cs. As you can see, it is a generic interface that takes the type of the primary key. That's why I named it T key. And we define a property named ID that is of type T key. If somebody calls it with iEntity of integer, then this is going to be int ID. If somebody passes a GUID or string, whatever type you pass for T key will be the type of the ID property. Next, we'll see how we can define an abstract base class named entity base. Entity base class is nothing but an implementation of the standard system.object methods, like the operator equals equals, not equals, and then the equals method followed by the get hash code and two string methods. These are the standard methods that you want to implement if you really wanted to support comparable interface. Next, we'll define the actual business object, which is called contact. In our case, it is going to have some standard properties like ID, first name, last name, email, phone number, birth date. And as you know, the first name, last name, email, and phone number are going to be string, and the primary key ID is going to be of type integer, and then the birth date obviously is going to be of type C# datetime data type. Now that we've seen this interface, abstract base class, and the model, let us go ahead and define them in Visual Studio Code. I'm going to switch to Visual Studio Code and start creating this interface, abstract base class, and the model. Okay, so I'm going to create a folder called models, and inside of that, I'm going to define the iEntity.cs and then the abstract base class named EntityBase.cs, and finally our model, which is contact.cs. Okay, so I define the interface, the abstract base class, and the contact class. Now let's move on to the repository classes and implementations. Okay, so here, if you look at it, I've defined a generic repository interface. You might be wondering, why do I need a generic repository? Why can't I create a specialized repository interface like iContact repository, iTask repository? If you notice it, most of the times the methods are going to be exactly the same methods. Like you want to get a single entity, you want to get all entities, you want to add, delete, edit, save, or search entities. Why do I have to define so many interfaces? So instead of that, I chose to define a generic interface that takes a type as the first argument and the type of the primary key as a second argument. So that is the motivation behind the generic repository. So you don't have to duplicate the same interface definitions for a particular entity. Okay, so the get is used to get a single entity based on the primary key. Get all is like get all the entities, and these four methods, you must be familiar with the term CRUD, CRUD, which is create, read, update, delete. It's the same thing: add, delete, edit, and save. And finally, the search is another useful method where you can use to search your entity based on the keyword. In case of a contact, I would be searching the keyword in my first name and last name property. But for a task, it could be based on a description and the owner of the task. And it's absolutely up to you to define what you want to search on. Next one is in-memory repository. Like I want to start with an in-memory repository implementation. And that's going to take a T and T key parameters, which is going to be inheriting the interface. So the first method, as you can see, it is going to be representing a list of T because it is all in memory. And then the get method is going to simply use the find method to check if the ID equals this past ID, and then if that is the case, then it returns that particular entity. Similarly, the add method will simply add an entity at the end of the list. Remove will remove the entity based on the ID that we pass. And then the edit will edit that, which is basically modify that, and save will persist it back to the memory, which is going to simply be calling the edit method. And dispose is very handy when you have to close the connection strings or something, when you're really wrapping it on top of the database or NoSQL or anything else. But in this case, in-memory repository dispose is going to be blank because it doesn't mean that we don't have any unmanaged resource to dispose. Search cannot be implemented because we don't know what is the type of the entity that and what are the properties of that entity to search on. So it's going to throw a simple exception called not implemented exception, and it says that search must always be implemented by the derived class. So that's the right thing to do. Then we will look at the actual concrete implementation that targets the contact model. So in here, in the constructor, before we jump into the constructor, if you look at it, here we are specifically mentioning the type T as contact and the type of key, which is T key, as integer. So which means that we're defining this as a specialized implementation that takes care of the contact type, which has integer as its primary key, as its ID property, okay, as the type of the ID property. Here I define four hard-coded contacts with my name and my family members' names. And then the save method is going to just look for the contact that matches the ID, and it'll find the index of that inside of the list. And if it is there, it's going to override that. If it is not, it's going to add a new contact, which is going to have the default values for all the properties. When you want to add a new contact, we find the maximum of the ID. In our case, it's going to be 4, and we add 1 to that. So it's going to be 5, and then whatever is the value for the other properties that you passed as your inside of your contact object, it's going to add it to the end. When you add the next one, it'll become ID 6 with all the values that you passed. Search, like I said earlier, it's going to use the find all method, and it's going to search in the first name and last name. If the first name or last name contains the keyword that you pass, it's going to return all those contacts that has this keyword in its first name or last name. So that's a simple implementation of an in-memory contacts repository. So let's now go back to Visual Studio Code and implement this contacts repository and also the interface and the base class, which is in-memory repository. Okay, I'm going to switch to code, and I'm going to create a folder named infrastructure. I'll create it at the root level. So I'm going to create a folder named infrastructure. I'm going to close all of this because they are distracting. So I'm going to say close all. And then now we go into the infrastructure and we define the interface first. It's going to be iGeneric repository. .cs. And then we'll define an in-memory representation called in-memory repository. And finally, we'll define our contacts repository. Okay, now that we've defined our repository interfaces and classes, we will start wiring these repositories into ASP.NET's dependency injection container. So dependency injection containers, like I said, there are so many popular containers like structure map, artifact, ninject, and so on. For this particular section, I'm going to only use the default dependency injection, which is now a first-class citizen in ASP.NET Core. So let us take a look at the DA methods and how we can inject our in-memory repository as well as the context repository. So we'll do that in the configure services method in our startup class. If you notice that I am defining a open-ended repository, which is iGeneric repository without any specific value for T and T key type parameters, which means that we're telling ASP.NET Core DA that I don't care about what is that value that's being passed for T or T key, just return an in-memory repository. In the next line, we also give a specialized declaration where we say that if the type parameter T is contact and the type T key is integer, always return contacts repository. And we are specifying that I want to declare them as singleton. So no matter how many times you ask, it's going to give you the same instance. So now let's go back to our startup.cs and we'll wire this in-memory repository and the context repository. Let me switch to code and we'll go into startup.cs. And in the configure services method, we will define that. Okay, right after this add MVC, we're going to say services.add singleton. It's going to complain about all these things because we have to define the namespaces for them. We can use the control dot and we can ask the help of Visual Studio Code to include this using modern.infrastructure. I think the contact is going to be in the models namespace. Yep. So now that we've told ASP.NET Core's DA container about our repository, now it's time for us to write the API using the controller classes. So let's switch and then we'll see how we want to define this API. Okay. So the first thing we want to do is we want to inherit this from the controller class. Like in the introduction of this series, I clearly mentioned that ASP.NET Core does not differentiate between the user interface controller versus the web API controller. That is, the user interface controller is the one that delivers the CSHTML markup back to the browser, whereas the API controllers will always return JSON. So in ASP.NET Core, there is not much of a difference. So it's up to you to return whatever you want. So I'm going to declare a contacts controller. And in here, if you see that I'm using the route attribute, let me go back to the previous slide and then show you that definition. Yep. So in here, I'm using the route attribute and then I'm prefixing my route with API and then I'm using the notation controller within square bracket. That means that whatever is the name of the controller, it'll take that, excluding the word controller. So it means that anything that comes to localhost :5000/API/contacts, that will be served by this API controller. And in here, I'm using the constructor injection. So I'm declaring a constructor called contacts controller, and then I'm taking the iGeneric repository of contact, integer. And if you remember in my previous slide, I had the startup.cs definition where I said if anybody asks for iGeneric repository of contact, int, you should always return a singleton instance of a contact repository. That's exactly what the DI container will do. It'll create a singleton instance and it will inject that into this argument. So whatever is being injected, it gets assigned to the this underscore contact repository field. And using that field variable, will be calling all the methods like get all, get, delete, and all the stuff that we've already seen in the repository. So technically, the API controller is very skinny because it uses the services of contact repository. So that's the best way to deal with this, because you don't want to be putting all of your business logic and all the stuff into this. So you'll just push them into a repository. Some people even go to an extent where they create something called as a service class called contact service class, where they abstract all the business operations. Like for example, if you wanted to do send an email to a contact or upload a picture of a contact and so on, you could define some service classes and you can inject those service interfaces also into this constructor, and then inside of your API methods, instead of you writing all the logic, you'll just delegate that call to the service methods. So in this case, I'm simply going to be focusing on the CRUD operations. So for me, the context repository is more than enough. So let's go to the next slide where you have additional methods like search and delete and all this stuff. So if you look at this here, I'm using the add. If you notice that I'm using a from body, which means that the payload of the contact comes in the HTTP body as a JSON string. So then the ASP.NET Core MVC knows how to deserialize it and then assign it to this contact model class that we defined in the previous slides. And then the route attribute is going to be used to override or tag the URL segment. For example, in this case, I say route attribute should be search, which means that it is going to be like this, slash API slash the name of the controller, which is going to be contacts, and then whatever you specify in the route attribute, which is going to be called search. And then the from body is going to say the keyword. The keyword is going to come in the body. Whatever you type, let's say for example you type MA in your text box, in the search text box of your user interface, it's going to pass that MA, and that's going to be the value of the keyword, and then it's going to search using the repository.search method, which is going to return all the contacts that has the word MA either in first name or in last name. Similarly, the delete is very straightforward. You're going to delete that contact based on the ID that you pass. For example, if you want to delete the contact with ID 1, then my name, this is Raja Mani, which is in the ID 1, will be deleted. Similarly, edit is going to simply pass the edit call, which is going to call the save method, which is going to look at the index of the contact using the ID and then replace that with whatever the contact that we pass. That is the modified values of contact. So that concludes the API. So let's go ahead and implement that API controller. I'll jump into the Visual Studio code and then go into the controllers folder, and I'll create a contacts controller. And then we'll copy and paste the code from our previously completed class. So I'm going to create contacts controller. .cs, and then we'll copy and paste the code from the finished solution. Okay, it's the same thing that you saw in the PowerPoint slides, so it's nothing different. So I'm not going to go over that all over again. So now we completed the API. Let us look at how we can test it using the tools like Postman or Fiddler. That is going to be the next section. So as you can see, the Postman and Fiddler. Fiddler is a tool from Telerik. Telerik is a company that specializes in building the libraries for .NET framework as well as the JavaScript library. One of the famous libraries, Kendo.js, which is also from Telerik. So Fiddler is a Windows application, and then as you can see, it has a composer where you can give the URL and you can specify the HTTP verb, get or post or delete or anything you want, and then you could send that method and then it's going to give you the response. Similarly, the Postman is a Chrome plugin, And here it also has the same look and feel. Like as you can see here, you can specify the verb and then the URL, and when you say send, it's going to give you the response. Most of the times the response is going to be in JSON because we're using JSON as our payload. People use XML as well, but of late JSON is the preferred payload format. Okay, so now let's jump back into Visual Studio Code. Let us compile our application. Let's launch the API endpoint, which is going to be in port 5000, and then we'll start running the application from the Postman or from Fiddler. Okay, I'm going to build the application by pressing Ctrl Shift B. And then once it's built, I am going to hit F5 to launch the Chrome browser, and then it'll just hit the home index, and then later we can just once the application shows up in the browser, we can start hitting it from the Postman or Fiddler. Like for example, for the GET request, you really don't have to use tools like Fiddler or Postman, but because the browser itself can make the get and post. But for other verbs like put, delete, and so on, it's always better to use another tool because browser cannot initiate that request. So for example, here we have API/contacts. As we know, it returns all the contacts. Let's see how we can do the same thing from Fiddler. I'm going to launch Fiddler. You can download and install it on your computer. If you Google for Fiddler, you'll be able to get to the download page. And the first thing I want to do is I want to just stop capturing the traffic and clear this. Okay, so now I'm going to the composer and I am going to type the URL, which I already typed in the browser. So I'm going to copy that and paste it. And if you just say execute, it's going to give 200, which means OK, HTTP OK result. And then you can see that it has a lot of views, like, it has a text view, it has got a raw view, it's got a nice JSON view, which can expand and collapse, and so on. This is how Fiddler works. I would also like to show you the Postman tool. Let's launch Postman. And as soon as it launched, we're going to do the same thing here as well. So here I could copy and paste the URL, and I'm going to clear all of this, and then I'm going to click send. It's going to give you the nice formatted JSON result. So this is just one of the verbs, get verb. Similarly, you could do the post as well as the put or delete. Like for example, let's create a new contact by using the tool. Let me go into the post verb. Then I have to specify the header. The header, we have to specify the content type as application JSON because we are going to pass. If you remember, we used the from body attribute definition in C# just to indicate that the body is going to contain the JSON string that represents the new contact that I want to add. So what I'm going to do is I'm going to take one of the existing contact. I'm going to just copy that. Then we'll go into the body tab and then I'll paste whatever I copied. Let's not worry about the ID because ID is going to be automatically assigned. And then I'm going to change the first name as Subi and the last name as Sridharan. And I'll give the email as Sridharan. This is a sample data, so, and then I'll just change some of the numbers here. And then like you can just say, okay. Okay, now let's see. We can send it, and then it should give me HTTP 200. Okay, good. So it succeeded. Now let's go back and then make a GET request and see if we get the newly added contact. There we go. As you can see, if you want to go to the pretty view, we can go to the pretty view, and you can see that the newly created contact shows up at the bottom with the ID as 5. And now let us try to delete a contact. Say for example, I'm going to delete the contact with the ID 1. So for that, I'm going to use the delete verb, and then I'm going to pass the value in the body, which is going to be the ID of the contact that I want to delete. So I'm going to just say 1. and then let's see if it deletes that. Okay, so then let's go back and then call the get method, and as you can see, my contact with the name Raja Mani, which is my name, and has been gone from the repository or from the backend. We deleted it. Let's talk about the put. Finally, put is to update or modify. So in order for us to do that, what I want to do is I'm going to just copy one of the existing um, JSON value, and then I will go into the put, and then I will go to the body. Let me paste it. All that I want to do is I'm going to just add an extra a here, and then I'm going to just say I'm going to just change the email address and let us send it. Okay, so that's also succeeded. Let me go back and then query the contact and see if the modifications that we made are all there. There we go. So we put whatever we modified, it's all there. Okay, so that is a demonstration of how we could use these tools to play with the HTTP verbs like get, post, delete, and put. Similarly, you can also make these calls from the client side. That's what we're going to see next. How are we going to wire these API endpoints into the contact service class on the client side? Okay, now let's jump back into the presentation, and we'll go over the contact repository on the client side and how we are going to inject that into the contact list and contact view, contact list and contact details view models, so they can use that new contact service on the client side that won't be talking to the local in-memory representation. Rather, it will go over the wire to the ASP.NET Web API that we just tested on Postman, and it will make a call on the server side. So let's go back into our PowerPoint and we'll resume from where we left. Okay, so writing the contact service in client side. The first thing that we want to do is we don't want to be giving HTTP localhost 5000/API, which is what is called as the base API URL. I don't want to type it over and over again. So I'll define a simple class called config.ts, and I'll define a static variable named base API URL, and I'll assign the base API of the URL of our API endpoint. And then in the contact service, what I will do is I'm going to be using a real HTTP client, which is going to be called fetch client. As you know, in the introduction, I've introduced two clients called HTTP client and an Aurelia HTTP client or Aurelia fetch client. The Aurelia HTTP client uses the XML HTTP request class, which has been there for a while, and the industry has been, the AJAX is built on top of that. But now there is a new standard called fetch standard, which is defined. We can check the Mozilla webpage where they define the fetch API standard. And then there is a new client that uses the fetch API. So that is what we're going to use in this section to implement our contact service. So if you remember, we had an in-memory contact service.ts, which is defined on the client side, which is also wrapping up an array of contacts. Instead of that, now we are going to rewrite those methods, but instead of using the in-memory contact service on the client side, we'll be using the HTTP fetch client to make a call into the ASP.NET web service or the REST endpoint that we developed just now. Okay, so the first thing is going to be the fetch client. We're going to import that, and then we inject that fetch client into the constructor, and we store it into a property called HTTP client. Then we call the init method. In the init method, we just configure our HTTP client with the base URL. So you don't have to type HTTP //localhost 5000/API for every call. Okay, and then we'll jump into the first method, get all, which is going to be like our select star style method, and it returns a promise. As you know already, promise is for asynchronous programming, so we can use a .then on the caller to wait for it to return, and then you could just get the return value and then render it the UI or do whatever you want. So here I'm using the HTTP fetch call, and then I'm giving the endpoint as contacts. As you know, the base URL is HTTP localhost 5000/API, and it is going to tag the slash contacts into the URL segment at the end. So it'll become HTTP colon localhost colon 5000/API/contacts, and then it'll wait for the response. As you can know, the async and the await is a pattern which is implemented in ECMAScript 7, also in TypeScript, to make the asynchronous call, and then it'll wait for the call to return. And once it returns, it assigns whatever the context being returned into a results variable, and we resolve the promise, and we set the is requesting to false. If you remember, we use this is requesting to display a progress bar, an Ajax progress bar in our shell. That's what is being used to to show the progress, and also it helps us to make it won't let us make multiple concurrent calls, because we don't want to do when there's another is requesting set to true. Okay, so that is the value of the is requesting flag. It's just a fake flag that we added to indicate that we are in the middle of a call. And the next one is search. As we know, we are going to be calling the contact/search endpoint, and we pass the keyword in the body, and then we'll wait for the response, and whatever the contacts returned by that API, the search API endpoint, is going to be assigned to a local variable result, and we'll resolve it. The pattern is pretty much the same if you look at all the methods. The get with an ID is going to simply call using this pattern contact/$of ID. We are using the string interpolation, so whatever is the ID, it's going to say contact/1 or 2 or whatever the value of the ID you pass, and then it's going to return that single contact. Okay, so the next one is going to be the save method. Again, it's going to call the contacts endpoint, but with this time with the put method. So it's going to go into the put. It's going to look at the ASP.NET Web API method that has the HTTP put attribute, and then it's going to go there and save this contact. And the create method is going to create a dummy, or called as a empty contact, but just bumps the ID to the next ID based on the last contact's ID. And then finally, we have the get contact index, which is helper method, which is used for deleting. So you just use the find index ECMAScript 6 method. It's called find index, which is not even implemented yet. So we use a polyfill, and if you use TypeScript, it comes out of the box with a polyfill. So we call the find index method, and then it returns the index of the contact that matches the ID that we pass, and then using that index we'll either replace it or we'll delete it. So that's the idea behind this get index method. And then I think there's going to be a delete method in the end. So yeah, we already saw delete, get all, and yeah, delete is right there. As you can see, it's here. So delete leverages the get contact index method. In actually in our case, we are not going to be using this, because we no longer use the client side helper methods, because we've defined a get index kind of a method on the server side API itself. So it's going to simply make a request to the contacts endpoint with the delete verb, and there on the server side we'll find the index, and then we have an in-memory representation on the server side, as you've seen, and then we are going to delete that based on the index on the server side. So there's no need for this get contact index on the client side at all. Okay, now let's go ahead and define that contact service on the client side. Okay, so we will now switch into the client side of it, which is under source contact manager. I think under services we want to define a contact-service.ts. Okay, we'll copy and paste the code from the completed solution. Okay, this is what we've seen in the PowerPoint slides. I'm not going to go over it again. And it is looking for the config.ts, which is where we defined our single variable called base API URL. So I'm going to just bring that also from my completed solution. We are going to define that in the common folder. We're going to create a common folder under source. and we'll create config.ts, and it's going to just have a simple class with the one public static variable called base API URL. Okay, now if you go back into the services, you will not see that error. Yep, so it's now available for you to import. Okay, the next thing that we want to do is to inject this contact service into the contact list and contact detail view models. If you remember, we are currently injecting the in-memory contact service. Now we're going to inject the actual contact service that talks to the backend ASP.NET Web API. The way we do that is we just import that contact service because we just defined it, and then we'll inject it instead of the in-memory contact service. We'll define the concrete contact service, and then rest of the method we don't have to touch because it's that one cool thing about using interfaces is that the implementation changes, but then the syntax of the method arguments, everything remains the same, so we don't have to worry about it. We'll do the same thing in contact-detail.ts as well. We'll import it, we'll inject it, and we'll assign it into a private variable like this, private contact service, and then that's it. We don't have to touch any other methods. Okay, so let's go and define the we'll go ahead and inject this into our detail and list. Okay, the first thing we want to do is to import the instead of the in-memory contact service, we want to import the actual contact service. I'm going to just copy and paste it, and I will just change this to contact service, and we also named it as contact dash service. Okay, so instead of the in-memory contact service, we'll inject the contact service, and also we'll change the type to contact service, and that's pretty much it. Because now we are passing a contact service, it'll call the methods in this class which are going to have the calls to talk into the actual backend ASP.NET Web API. We need to do the same thing for contact detail as well. Okay, so we'll copy this line and we will change it to contact service, which is now going to point to the ASP.NET Web APIs. Then we will change the type of the injection parameter to contact service, and also change this, and now it should be calling our ASP.NET Web API. Okay, so let's go back and we will launch our application by running npm start. Okay, so let us do that, npm start, and let's see if all of our client changes that we made are going to compile and run without any problem. Because first it runs the TypeScript transpiler and see if there's any errors, and if there are no errors, it's going to serve the application from localhost 9000, and when we hit localhost 9000, it's going to load the contact manager, and the contact manager is now going to use the contact service, which is going to make the call to the actual backend. Okay, these are warnings. These errors are not serious errors. Let's go back to the browser where we have the contacts. Now let's load. I'm going to maximize this so we can see them fully, and then we'll also load the debug tools or developer tools, and let's see if it works. Okay, how do I know if it really made the call to the backend or not? Let us go ahead and put the breakpoint into our contacts controller. And what we want to do is I want to put the first I want to put the breakpoint in the contact repository in the get all method. So let me do an F5 again. It should hit that breakpoint now. Yep, it hit the breakpoint. As you can see, the call came over the wire into this method, and I'm going to hit F5. Boom, it's going to return all the values. So let me go ahead and edit it. So I'm going to fix this email addresses and spelling mistakes and all this stuff. So let's see, and if I click on save, it should go into the post method. So I'm going to put the breakpoint into this HTTP. Actually, HTTP. Let me see if it's going to go into the edit method, I guess, because that's where I've wired it. Let's go check the save method. Let me put a breakpoint here. and let me hit the save method. Yep, and it's going to call the HTTP put, and in the from body you'll see the contact is coming. So if you mouse over that, it'll show the values that we changed, because instead of John Shirani I changed it to J Rani. And now I'm going to say go. As you can see, the name's changed. So let's try to add a new contact, and then we'll also try to remove the contact. Let's say, for example, we'll remove this contact. Okay, when you click remove, which is going to go into the HTTP delete endpoint. So let me click remove contact. As you can see, it entered the delete, and let's click go, and it's going to refresh the view by calling the get all again. So that contact is gone. Let's create a new contact. I'm going to call sormani@gmail.com, and then I'm going to give some random date of birth. Okay, let's click on save, and then it'll go into that put method again, and then it will store this. And as you can see, it is saved. When we go back and type browser, it comes back. And then but one of the things is, since we are using only the in-memory rep, okay, it's going to refresh immediately by calling the get all, but I didn't notice the breakpoint being hit, so I'm going to hit go. So it's going to refresh this list. So it's very simple. It's a simple CRUD operations. We've seen create, read, update, delete. Okay, so that concludes the section 5 of part 5. Until we meet in the next part or next section, happy coding.